So, um, the other day I gave an AI what I thought was like a super simple multi-step task.
Oh no, I think I know where this is going.
Right. I just needed it to organize some data, draft a quick summary, and I step away to grab a coffee. I come back maybe 5 minutes later, and it has completely lost the plot. It was literally writing a poem about spreadsheets.
A poem about spreadsheets. Yeah, that sounds about right for older models.
Yeah, but in the stack of OpenAI API documentation you shared with us today, there's actually a blueprint for fixing exactly that problem, which is our mission for this deep dive. We're unpacking the GPT 5.4 API prompt engineering guide so you can, finally get an agent to reliably finish the job.
It's a critical shift in how we approach these models. GPT 5.4 it's specifically engineered for production-grade agents and long-running tasks. But to unlock that potential, you really have to stop treating it like a standard conversational chatbot.
Before we get into the weeds of how to actually do that, let's talk about building the right framework. This deep dive is sponsored by Embersilk. Need help with AI training, automation, integration, or software development? If you're uncovering where agents could make the most impact for your business or personal life, check out embersilk.com for your AI needs.
So getting back to that framework, the documentation highlights this concept of agentic workflow robustness.
Which sounds very technical.
It does, but basically it means the model is remarkably good at maintaining its logic over massive sequences of actions, assuming you give it the right framework. The core takeaway from the sources is that it still needs you to explicitly define what done looks like.
Okay, so how do we do that?
The guide strongly recommends hard-coding a verification loop into your system prompts before the AI takes any irreversible high-impact action.
Like firing off a final email to a client?
Exactly. Or executing code. It must be instructed to pause, read its own proposed output, and verify it against your original constraints.
Oh, wow. So you're forcing it to double-check its work. That makes sense for preventing catastrophic errors. But how does that apply to just standard research accuracy? Because one of the big selling points of this model is what the guide calls evidence-rich synthesis.
Right, and you leverage that synthesis by locking the model into a strict research mode. You demand exact citation formats.
Like requiring specific bracketed footnotes.
Yeah, you mathematically force it to map its outputs only to the retrieved evidence. By imposing those strict formatting rules, you strip away the conversational ambiguity that usually causes a model to improvise or hallucinate references.
Wait, though. If GPT 5.4 is so smart with evidence synthesis, shouldn't I just go into the API and crank the reasoning effort dial to maximum? Doesn't throwing more compute at the problem automatically solve my bad prompting anyway?
That is probably the biggest misconception developers have right now. Yes. The reasoning setting is just a last-mile tuning knob. It's not a magic band-aid for contradictory instructions. When you crank that dial to high, you are forcing the model to generate exponentially more hidden thinking tokens.
Right.
If your baseline prompt is ambiguous, the model just spends all that extra compute wandering down the wrong logical path.
It just burns through your API budget.
And destroys your latency. You should default your reasoning effort to none or low for basic execution tasks. Fix your prompt logic first and only reserve medium or high for deep multivariable research.
That is a huge tip. It's less about treating the model like a magic black box and more about giving it deterministic constraints. And speaking of under-the-hood control, your notes highlight a couple of fascinating API parameters designed specifically for these giant, complex tasks.
There are two mechanics you really need to understand here. The first is the phase parameter. By setting the phase to reasoning rather than execution, you actually force the model to hold its thoughts in the tool call loop before it writes the final output. It prevents the AI from prematurely outputting a user-facing response when it should still be analyzing data.
And the second one is compaction, right?
Yeah.
The documentation makes it sound like a total game changer for long-term memory.
Oh, it is. Compaction operates like semantic token compression. Instead of just truncating a long chat history when you hit the token limit, it encrypts and drops older conversational context out of the active window.
But it keeps the rules.
Exactly. It mathematically retains the core logic and rules you established weeks ago.
That application is huge for you listening right now. By utilizing these tools and defining clear output contracts, you transform the AI from an unpredictable text generator into a highly disciplined, tireless assistant that never loses the plot.
And it paints an incredibly optimistic picture for the future of our digital workflows. We are building intelligent tools that amplify human curiosity and solve complex problems. The solutions we can build with these reliable agents are going to unlock limitless potential for human progress.
I love that. If you enjoyed this deep dive into the sources, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.
And I'll leave you with this final thought. If an AI can now hold perfect context across an endless compacted conversation, wait, scratch that. If an AI can hold perfect context across an endless compacted conversation, how will having a permanent, deeply knowledgeable brainstorming partner change the way you tackle your life's biggest dreams?